In this video, we're going to take a look at parabolas. And specifically, we're going to take a look at what a parabola is, first and foremost, as well as how to sketch the graph of a parabola by first finding its vertex and x and y-intercepts. Now remember that a parabola is just simply a conic section. The graph of any function in the square family is called a parabola, so the graph of a quadratic function is also a parabola. This here is a quadratic function, so it's defined to be a parabola. Now I want you to first convert that parabola into this form here that I'm circling, and in order to do that you're going to have to complete the square. Now in order to complete the square, you're going to have to make sure that the coefficient in front of the x squared must be a 1. So you need to somehow think about how we can get rid of this 3 in front of that x squared and make that coefficient in front of the x squared a 1. Then complete the square so that it follows this form here. Now once in that form, I want you to find the vertex as well as the x and y-intercepts and then simply graph the function. Now remember, if your parabola is in this form right here, the vertex is really simple. The vertex is just simply hk. Now if your parabola is in the previous form, this one right up here, then the vertex is a little bit more complicated. Now you can do the vertex in that form, and I will show you how to do that, but I first want you to try this example on your own. Find the vertex once you've converted it into this form right down here, and I want you to find the x and y-intercepts. Now x and y-intercepts are real simple. Remember that an x-intercept is found by simply setting y equal to 0 and solving for x, and a y-intercept is found by simply setting x equal to 0 and solving for y. So go ahead, pause the video, and try this example on your own. So as previously stated, in order to convert this parabola here in the quadratic form into this form right here, what we're going to have to do is complete the square. Now in order to complete the square, we need, like I said, that coefficient in front of the x squared to be simply just a 1. So in order to do that, I'm going to factor a 3 out of the entire equation. Now if I do that, I result with x squared minus 2x plus 5/3. Okay, so just to make sure that we haven't done anything wrong, let's take a look that if we were to FOIL this 3 back into this equation here, we would result with the original question, which we do. So this is working out well. We haven't done anything wrong. Now in order to complete this square, remember, to complete the square, we just take this coefficient in front of the 2, we split it in half, so that becomes 1, and we square it. And so we're going to add and subtract a 1 inside of that bracket. Now if you take a look at this portion here within the round bracket, we can easily factor that to a perfect square. Your perfect square would just simply be x minus 1 squared. Now this portion here are just constants that we're going to add up. So like I said, under the red parentheses, we're just going to complete the square. It's a perfect square, so the 3 stays untouched. Put a nice big square bracket here. We're completing the square to be x minus 1 squared. So that takes care of what is highlighted in the red parentheses here. And then the negative 1 plus 5/3 reduces to positive 2/3. Okay, and lastly, all we need to do is FOIL this 3 inside the square bracket. So we're going to FOIL it to here and also here. And so what we result with is 3 times x minus 1 squared plus 2. And so now we've converted the quadratic equation into this form here. So now it should be real simple in finding the vertex and x and y-intercepts. Okay, so in this form here, the vertex is simply hk, where h is this value of 1, and k here is this value of 2. So your vertex is just simply 1, 2. Now let's think about the opening of this parabola. Now remember that the opening of a parabola can be told by that value of a here. So our value of a is actually 3, which is positive. So if your a is larger than 0, which is a positive a, then the opening of your parabola will open upward. Whereas if your value of a was negative, then the opening of your parabola would be downward. So our opening of the parabola, since 3 is positive, it's greater than 0, our opening would be upward. Now if our vertex is at the point 1, 2, and the parabola is opening upward, well, what does this suggest? This actually suggests that we don't have any x-intercepts. So we will look at the y-intercepts, but just to kind of clarify what I mean, let's scroll down to the graph here. Our vertex is at the point 1, 2. So at that point 1, 2 is roughly right here. That's the vertex, which means it's the base of your parabola. And the value of a is 3, which is positive, so that suggests that the parabola is going upward like this. Which means if your parabola is going upward, then you're never going to cross this x-axis down here, which means you're never going to have any x-intercepts. So we have no x-intercepts, but what about the y-intercept? Well, the y-intercept is when we set x equal to 0 and solve for y. So here, with our function, if we set x equal to 0 and we solve for y, what do we get? We'll get y equals 3 times 0 minus 1 squared plus 2. Now this reduces to y equaling 3 times 1 plus 2, where y is then equal to 5. So the point 0, 5 is your y-intercept. And again, we have no x-intercept since a is equal to 3, which is larger than 0. This would suggest that your parabola opens upward, which means we would never cross that x-axis since your vertex is at 1, 2. So let's now draw this parabola based on the information we have here. We've already plotted the vertex at the point 1, 2. We don't have any x-intercepts, which means our function will never cross this x-axis here. The parabola is opening upward, so it's going up this way, and the only other information we have is the y-intercept here of 0, 5. So that just suggests that when x is 0, y is equal to 5. That's at this point right here. And so a rough sketch of our parabola would just simply be like so. Now how would we go about finding that vertex if our function were to stay in the quadratic formula function? So for example, here our function follows the quadratic formula, where that means fx is equal to a x squared plus bx plus c. And that's a quadratic form, so how would we find the vertex given that form? Well, the x-coordinate of your vertex is just simply negative b over 2a. So for your x-coordinate, our b value here is negative 6. So negative 6 gives me positive 6 in the numerator. And then our value of a here is 3, so 2 times 3. Now this reduces to a value of 1, so your x-coordinate is 1. Now your y-coordinate is found by taking that x value and subbing it into your function. So it's basically at the point negative b over 2a, which is equal to 1 in our case, so it's our function at that point 1. So simply just plug in 1, an x value of 1, into your quadratic equation. So 3 times 1 squared minus 6 times 1 plus 5 actually works out to a value of 2. And so that's your y value. And so your vertex point is at that point 1, 2, which is what we found previously in the different form.